Hey everybody, today we're going to be doing 3-2 measures of variation. Key concept, variation is the single most important topic in statistics. So this is the single most important section in this book. This section presents three important measures of variation: range, standard deviation, and variance. And when we talk about variation, we're trying to figure out what our values are. Are they really closely tied together? Are they all over the place? For example, let's talk about heights of the population of men. They don't vary that much. They may vary by maybe 6 inches at most in general. Now, we have people that are not very tall and we have people that are very tall. Those are at the edges of our numbers, but most people are in a certain range. And that's what we're going to talk about. These statistics are numbers, but our focus is not just computing those numbers, but developing the ability to interpret and understand them. The range basically just means the maximum value minus the minimum value. We'll do some problems. I'll show you how to find it. For example, we have these values and we want to find the range. So we find the biggest value, 55.6, and our smallest value is 14.1. We subtract those two values and we get our range. That's really all there is to it. It tells us a lot of information. And if you remember from the last lecture, we talked about things that are resistant. Would you say range is a resistant value? Think about it for a second. If I had one outlier, let's say also here I had 1,000. Now, my maximum value minus my minimum value is way different than this number. It would be 1,000 minus 14. It is not a resistant value. Standard deviation of a sample. The standard deviation of a set of sample values, which is denoted by small s. The notation is small s means we're taking a sample, and this is a Greek letter called sigma, and it represents the standard deviation for the entire population. And it's a measure of how much data values deviate away from the mean. For example, we're going to learn about bell curves today. But let's say we have a bell curve that looks like this. And in the middle of the bell curve, we always have the mean. If this is our bell curve, then we can see that the data is spread out a little bit. But if I take the same shape and I draw it just a little different, what if our shape looks like a bell curve that looks like this? Well, the mean is still right in the middle, but notice most of our values are much closer to the mean than they were with this other shorter graph. We might have the same amount of data in here, in this red area, as in this blue area. It's just arranged different. We would say that the red bell curve would have a smaller standard deviation than the blue because they're going to deviate more. They're not as close to the mean. Calculating the standard deviation. I'm going to show you here how to calculate the standard deviation, and we're not going to do these calculations. We're going to use StatCrunch. But I do want you to understand how we're getting these values and where they're coming from. It's telling us here that our mean is 30.7. It's a sample mean, that's why it's X bar. Remember, this means to sum. We would add up X minus X bar. These are my X values. This would be the same as saying 38.5 minus X bar is 30.7. And then we square it. Plus 55.6 minus 30 30.7 squared plus 22.4 minus 30.7 squared plus 14.1 minus 30.7 squared plus 23.1 minus 30.7 squared. If you do all this work, you should get this value. And then we're going to divide by n minus 1, where n is the number of values. So I have 5 values here. 1, 2, 3, 4, 5. And minus 1 would be 4. So we would take all these numbers and we would divide by 4, which is what they're saying here. We would then take the square root and we would get our standard deviation. Now, we're not going to do that. I just want you to see that really what you're finding here is the distance this data is away from the mean. And you're squaring it because that makes it positive. Because some of these would be positive and some of them would be negative. They would add and subtract from each other. So we square them all and then we take the square root. Okay? Of a population, it's a little different formula, not much, but when we're talking about the entire population, then instead of dividing by n minus 1, so we're dividing by this capital N, which is the number of people in the population. We're using sigma instead of S for standard deviation because it's the population. And here we're just summing all the values minus the mean. Mu is the mean for the population, and we square it. It's really very similar to the other one, except now we're using more data values. We have this range rule of thumb to identify significant values. Range rule for estimating the standard deviation. We find the range and divide it by 4. And that is an estimate of the standard deviation. Here is my mean. And here is one standard deviation away. And this is 2 standard deviations. That's why it's saying it's the mean plus 2 standard deviations and the mean minus 2 standard deviations. All the values in here are really not significant. But once we get out this way and this way, more than 2 standard deviations or less than 2 standard deviations away from the mean, we're talking about things that are significant, that they don't just happen by accident. If I said that the average height of a male is 5'11", and I had somebody who was 7 feet 2 inches, that would probably be way out here. Sometimes we want to look at if it's significantly high or significantly low. We might find somebody who's 3 feet 6 inches tall. That would be significantly low value.